Department of EEE France Xavier Engineering College, Tirunelveli welcomes you all. Electrical and Electronics Engineering Department was started in the year of 2002. The department is functioning with 2 PG courses such as Power Electronics and Drives was started in the year 2011 and Power System Engineering was started in the year of 2013. We got recognized research center status from Anna University Chennai in the year 2017 and our department re-accredited by National Board of Accreditation, New Delhi from 2017. The department has a strong faculty strength who are committed and are specialized in various streams of electrical engineering. Also, we have DST, FIST supported Advanced Power Electronics and Drives Laboratory and National Instruments Power LabVIEW Academy.
Good morning to one and all present here. It gives me the immense pleasure to welcome you all on this seminar session under the topic Electrical Machines for Electrical Vehicle. This webinar is hosted by the Department of EEE of FXEC on behalf of our chairman Dr. S. Babu, our managing director Mr. Arun Babu and our general manager development Dr. J. Kumar. I welcome all the heads and faculties from various institutions and the alumni of FXEC. Now, my hearty welcome to Dr. Vel Murugan, our beloved principal, and our HOD, Dr. P. Anapandi, for organizing this event in a successful manner. My hearty welcome to Dr.S.Allirani, Associate Professor, Sri Ramakrishna Engineering College, Coimbatore. She has a teaching experience of 23 years. She published up to 23 journals publications and she proceeded 30 conference publications. Now, I hand over the session to Dr. S. Allirani to proceed the webinar. Thank you.
Hello. Good morning, everyone. I am Dr. S. Allirani, working as Associate Professor in Sri Ramakrishna Engineering College in the Department of Electrical and Electronics Engineering. Today, I am going to present a topic on electrical machines for EV applications. I now happy to thank Francis Xavier Engineering College, the management, principal, and head of the department, Professor Shobhana ma'am, for giving me this opportunity to deliver my knowledge, to share my knowledge on electrical machines to the viewers. So I wish to present my PPT. Please bear with me for 2 minutes. So today's topic is electrical machines for electrical vehicle applications. Why this topic? Why this EV is trending now? That is the basic thought process or basic question comes to all of our mind. Why electric vehicle nowadays is booming up? It's because of the 3 reasons. One is we need eco-friendly systems. We need eco-friendly systems in order to safeguard our environmental from pollution and other kind of issues. So the second point is we have to protect our earth from hydrocarbons, because global warming is emerging now, is another issue which we have to face. Then the another important scenario is fuel price. Nowadays, fuel price is increasing tremendously. So we have to find the alternate and we have to save our earth from all these things, from all these issues. So now we are urged to have electric vehicle all over the world. So where we are now in the world as well as in India, and what are the opportunities we have on EV sector. So all those things I just want to give a glimpse on one portion of EV sector, that is on electrical machines. So if we see the history of electric vehicle, it is started in 1800s. In 1800s, if you see, in 1832, Robert Anderson and Thomas Parker, they introduced that electric vehicle, which is actually the electrical carriage, first motorized carriage. It was an electric vehicle, but that had no rechargeable battery. So that is the first EV which is came up, and then the real electrical car, which is came up in the year 1890s or 1889. So the first successful electric car made is made up of, it is introduced by William Morrison. So that 6-passenger car was capable of top speeds even up to 14 miles per hour. And then so it is continued. Then the electric car is adopted in 1900s. So fully more vehicles came up, and in 1908 and 1935 around, up to 1935, especially Ford, they introduced Model T EV, so which was very much developed, and which was made EV in the until 1935, the EV sector is boomed up. And then in 1935, our electric vehicles started disappear because of the actual reason behind that is, in 1920s, the US had a better system of roads connecting cities. Americans wanted to get out of that and explore. And with the discovery of Texas crude oil, gas became cheap and readily available for rural Americans. So automatically, what happens? The cost of EV become more compared to our IC engine. So that time it was stopped. So this history gives us that this EV sector started even in 1800s. And then again, it was disappeared in 1935, and nowadays, from 1990 onwards, we are coming back to electric vehicle sector. So on the left side, if you see that trend return of electric vehicles in international market, in 1991, Quebec and latter body, 1997 Toyota Prius, and 1999 Honda Insight, and 2001 Reva electric car, and then in 2008 Tesla car, and 2010 we got Nissan Leaf, and it continues. The list continues. So in this scenario, another history on electric vehicles, that is timeline. Again, it starts from, it is between the period 1800 of vehicles, which is starting from New York, a fleet of taxis, which was introduced in 1897. And then recently in 1997, we got Toyota Reva vehicle. And so it is shown on the figure, just for your understanding, from which year it is started. And after 1997, again, it is again continuously improving, and nowadays we are urging to still grow fast in order to save our earth and other kind of hydrocarbons. So this another picture which is showing that the first car, and recently in 2020 we get a Toyota Prius and even BMW i3 vehicle. All those vehicles are recently luxury cars which came up with electrical machines, electric motor. So this history is shown here in two different way. So up to 1997, the top picture shows that, and recent vehicles are shown on the bottom picture. And then we get into our vehicle. not electric vehicle, our car. And here I have considered only four-wheelers. Even in two-wheelers, many of the industries, they started, many of the industries and market potentials they introduced, and now on road we could see a lot of vehicles. And recently Ether Energy in Bangalore, they developed one two-wheeler which is most welcome by all the two-wheeler lovers because of its high speed capability and other kinds of advantages. So now, because in two-wheeler, the electrical machines which we are using in two-wheeler is normally hub motor, that is BLDC motor. And there are here and there the research is going on to replace that hub motor with induction motor. That BLDC motor, since it has permanent magnet in it, there is a alternate kind of, in order to increase the pickup, and range, alternate motors are seen for that. That is under one side, that is under research. The four-wheeler, if you see the IC engine main parts, so it has IC engine, and that engine is shown in green color. And then we have a transmission, and the transmission which is coupled with the differential, and the differential, through differential, the axles are coupled here. So this setup is available in the, it is a drivetrain which is there in the four-wheeler. So now how this drivetrain is going to be converted into EV, that is how the motor is going to function or replace the function of IC engine. So here this figure shows you, you can see that axle portion, and then the motor, drive motor is there. So drive motor, in this figure, the drive shaft is there. So in a drive shaft, through drive shaft, the engine drives the wheels. So similarly here also, the drive motor, which will through this gear mechanism, it is coupled with the axles is connected to the differential through transmission to the through gear to motor, and motor is supplied by battery. So the red arrowheads are showing the electrical power flow, and blue arrowhead which is showing the mechanical power flow. So this reducer, actually this image is taken from one of the gear manufacturer's site. So on this they have shown that reducer is the gear mechanism which is available. So why do we need gear in this motor is sorry, this engine is in order to we have to see the operating cycles, the driving cycles of the engine. So normally we have the normal flat road drive cycle, that is on road without any ups and downs on the road. And then the next one is uphilling. Uphilling means, so we have to drive the vehicle on the slope area. So that time we need more torque. So automatically what happens, when the torque increases, the speed will be reducing. So the gear mechanism will do that function. So that reducer that will give that changes of speed and torque in proportion to the drive characteristics of the engine. Engine means drive characteristics which is required by the vehicle. So drive motor is there, and from, we all know that battery is there. And normally from battery through inverter, the drive motor is given supply, and which is driving the car. And this is another. So this is in normal mode of operation. In normal mode of operation, during motoring mode, During motoring mode, the vehicle drives the motor drives the wheel, and the vehicle is moving. In this powertrain in regenerative mode. So in regenerative mode, what will happen? In regenerative mode, that is while we apply the brake, there are two modes of operation, like acceleration and deceleration, as we know, related to the drive or motor. We call it as acceleration and deceleration. So here acceleration is there. We will be increasing the speed, acceleration, and deceleration, that is while applying the brake. While applying the brake, what happens? Since we are using motor, it will be operating in regenerative mode. So the motor, now the drive motor will act as a generator. So the power will be taken back to the battery. From the wheel, the motor will act as a generator. That means the mechanical energy is converted into electrical energy, and through inverter again it is stored in the battery. So this is regenerative mode. And types of EV, if we see the types of EV, electric vehicle, we have a hybrid electric vehicle, plug-in hybrid electric vehicle, and BEV, that is battery electric vehicle. We call it as HEV, PHEV, and BEV. So HEV, you can see this image. So this image is showing us HEV, that is a hybrid electric vehicle, means both battery will be there. That vehicle will be operated by battery as well as IC engine. So here there will be a load sharing, or there will be a parallel operation sharing, like when during normal drive cycle, that is normal operation on flat road, and the battery will be sufficient to supply the motor, and motor will drive the car. Suppose in uphilling, or while we give some acceleration, that time this power will not be sufficient, battery power will not be sufficient. So that time we have to switch over to the mode of IC engine mode. So this is a hybrid electric vehicle which will be operating in both the modes of operation. And then the plug-in hybrid vehicle. So plug-in hybrid vehicle, in which the battery will be there, electric motor. So this ratio will be more. The battery has to be charged, so it also has both the electric motor, and the battery capacity will be more, and at the same time the IC engine will also take part. The only thing is the ratio will be comparable. And then coming to the BEV, that is fully battery electric vehicle. That is what our aim, to replace all the vehicles which are there in the world. That has to be fully replaced by battery electric vehicle, so that the environment will be fully, that is green environment we can ensure. So that is a battery electric vehicle. So this is one kind of classification, or we can say types of electric vehicle based on the operation. That is whether it is operating based on the operating mode, whether it is operated in fully through fully battery, or partly from IC engine. And this again, the drivetrain. There is another modes of operations. How the wheels are, how the car is driven by the motor. So there are actually 4 modes of operation. So it may be single wheel drive, that is a single drive. We can call it as front wheel drive. It is front wheel drive or rear wheel drive. We can have both. So in this, you can see that wheels are coupled. In this image, you can see that the front wheel, which is which is connected to the engine, that is motor, and which is driving the car, and rear wheel will be simply it is running. And in this rear engine, we can see in rear engine, the rear wheel is having the full control, will be operated by the motor, and front wheel will be running without any having connected with the motor. And this is the second mode of operation, that is front wheel drive or rear wheel drive. And we have the next one is all wheel drive or four wheel drive, This four wheel drive, normally this will be used in sports car, like high speed vehicles, the multi-motor drive. We can call it as multi-motor drive or all-wheel drive or four-wheel drive. What happens? Each wheel will be coupled with the motor, and the car or the vehicle will be driven by all the four motors. So there must be a coordination between all the four motors, synchronization with the motors. So the signal, the motor control unit will be complicated in this four-wheel drive, but we can have a full controlled performance with this four-wheel drive or all-wheel drive. So the same points which is in one diagram I have, just for giving clarity, I have included that slide. And this is an electric vehicle in the top view. So you can see this where to keep the battery, engine, and then motor is there. Then we have the clutch, and the battery is also kept on the right hand side. Inverter is there. So it will be giving 7 automatic speed variations or 7 speed adjustment through this transmission. So lithium ion battery is normally used with all the motors so far. So this is so far I have given an overall view on electric vehicle. So what is the function of motor? What is the function of machine in an electric vehicle? So what we are expecting from the electrical machine is better performing torque speed characteristics, better performance on torque speed characteristics. Or what is expected is torque speed characteristics which is giving different operating cycles of the vehicle. So the machines which are normally used for EV applications, I have listed out. Conventional machines, we have induction machines and synchronous machines, that is there, which we name it as AC machines. And then from conventional machines, even DC machines also can be used, but nowadays we are moved into AC machines after the revolution of power electronics. So I have considered only AC machines and special electrical machines. So this special electrical machines, we have a brushless DC motor and permanent magnet synchronous motor and switched reluctance motor, we call it as SRM, and synchronous reluctance motor. And apart from this conventional machines and special electrical machines, we have one more category that is recently evolving, that is axial flux machines. Actually, axial flux machines are, it is evolved in the previous years also. And for electric vehicles, especially, this axial flux machine can also be considered, can also give better performance. So now we are going to see how these machines are going to perform with electric vehicle and how to find the suitability of the machine for a vehicle. So if we take this EV propulsion motors, that is motors used in electric vehicle, what are the expectations from that machines is, or what are the performance we are expecting from the machines is, first point, that is we are expecting high efficiency in all driving cycles, in normal mode, in regenerative mode, in uphilling mode, braking, all the modes. We have to get the higher efficiency and higher starting torque. And because high starting torque means we will be getting good start, that is the acceleration will be high, so that we can quickly get into the normal speed range. And then wide operating speed, so that we can increase the range of the vehicle. Range is nothing but with one battery charged or fully charged battery, how much distance I can cover, whether I can cover 100 kilometer, or I can travel 200 kilometer. So now the recent development is, I think 400 kilometer range is on road. So wide operating speed and high power density and better power factor and small size, and as well as low cost. So these are the good characteristics, or we can say the expectations from the motor used in electric vehicle. So we will see how these machines, the induction machines, synchronous machines, reluctance machines, all are going to meet these characteristics one by one quickly. So induction machine, almost induction machine can give all these points. Mostly it covers all these points. And so the first initiative is with the induction machines. Induction machine, Tesla car is with induction motor. It is came up, and then later in recent Tesla car Model 3, they have again used PMS, permanent magnet synchronous motor. I will tell you the reason. So the limitations of induction motor, if we see, compared to synchronous motor, that is permanent magnet synchronous motor, the induction motor will have slightly lower efficiency compared to permanent magnet synchronous motor. Then it has high power losses, because we know the stator and rotor both has windings. So when we have copper on machines, automatically the copper losses will be high. And at the same time, the operating induction motor power factor is always, compared to synchronous motor, induction motor power factor will be lower. And then the rotor losses will be there. It can be reduced. By properly choosing the rotor design. And the induction motor, here we have to, so induction motors are used in Tesla car. I have given some of the examples, like Tesla, Audi car, and Mahindra Reva car, which came up in 2001. That Mahindra Reva car, which used I think 15 kilowatts induction motor, and now they came with the new version of the electric vehicle. And Tesla has also introduced first Tesla car which is with the induction motor. Then they moved to permanent magnet synchronous motor. So in this you can see this electric vehicle which is controlled, or which is driven by induction motor. So apart from this, we are talking on motor alone. So the control, the speed control concept, speed control of induction motor, how the speed of the vehicle is controlled is, normally in all the vehicles, whether the vehicle is using induction motor or synchronous motor, permanent magnet synchronous motor, the field-oriented control technique. The speed control of motor is done with field-oriented control, or we can say vector control. We can say vector control. So here we can see that field-oriented control. In this diagram, you can see the wheel is coupled with the induction motor, and the wheel speed that is measured and which is given to this control block. That control block gets speed as the signal, feedback signal, along with the current. The current and normally voltage will also be taken as the feedback signals. So the current and speed is taken, and from that current and speed, the required speed, that is what speed the vehicle has to be moved. So whether we need to increase the speed or we need to decrease the speed based on the application of based on the brake applied or acceleration given, the induction motor will get input power from the battery. So we have lead acid battery here. This is the very first beginning. Lead acid battery is used, and then recently we are going with lithium ion batteries, and nowadays on all the vehicles lithium ion batteries are used, and further new batteries are under research. This induction machine, you can see on left side we have two images. One is induction motor, that is normal induction motor cutaway view, and it has if you see induction motor, why induction motor is preferred is it has rugged construction, and it needs less maintenance, and it gives good efficiency at all the operating modes, and the speed control is wider, and we can get required torque, and when we use even slip ring induction motor, we can increase the starting torque also. So that is why normally induction motors are preferred for any of the industrial applications. So now it is used in EV also, but as special electrical machines came up, this induction motor is slowly replaced by the special electrical machines, especially permanent magnet synchronous motor, and the switched reluctance motors is also coming up. So the down one, which is again induction motor, in Tesla model vehicle, we have the same induction motor which is there on the top, which is given along with the controller module. So on right, you can see the graph which is showing the here two characteristics I have shown. The top one is the operating cycles. Operating cycles of the motor is shown. That is, the motor can be operated in 3 modes. So constant torque region and constant power region, and then breakdown, or we name it as series motor operation. So normally this constant torque region, in normal mode of electric vehicle, the motor will be operated in constant torque region, and then when we increase during acceleration and deceleration, we may be operating in constant power region. So accordingly the motor will be operating in this 3 modes, any of the 2 modes normally. And the down graph, which is giving the classification of machines, especially induction machines. That NEMA is National Engineering Manufacturers Association, which is classifying the induction motors based on its torque speed characteristics. So we have class A, class B, class D, and class C and class D. If you see, there is one more class E is there, and class E motor we call it as IE motors, that is international efficiency all IE standard motors are class E motors, which are having the efficiency more than 92%. 92%, and now even IE2 is having efficiency of 92%, and then IE3, IE4, now IE5 motors are also coming up in industries. And so this will be giving you how the motor can be designed in such a way that it can be operated in any of the torque speed characteristics. For example, if you see this design D, class D motor, whose starting torque is the maximum torque. From the graph, you can see the starting torque of design D, that is with the high starting torque, I can design one motor. So where we need high starting torque, there we can use this class D motors. So this is a NEMA standard, which is normally we have to, at least minimum, we have to use IE2 motors in industries. It should not be below that in that standard. That is one point you can understand on electrical machines. So the top one, the operating cycles of. So what will happen with your EV? That is when it is going in uphilling mode, automatically the will be reduced. So that is why we are going with the gear mechanisms, so that it will increase the torque. When we increase the gear, and the speed will be increasing and torque will be decreasing. So while moving in uphilling, we have to choose proper gear and run the IC engine. In the similar way, we have to operate the motor also in this characteristics, where we have to fix the motor operation, that we have to fix. And another point is, when since motors are operated with battery, if it need to operate at a high torque, then it's supposed to take high power as the input. So when power is required more from the battery, then the battery will be drained fast. So automatically the range will get reduced. So what happens? Either we have to go with higher rated battery, or we have one more another alternative, that we can use supercapacitors, so that the supercapacitor along with battery, ultra capacitors or supercapacitors. So the supercapacitors, what it will do is, it will boost up the energy, so that the acceleration mode can be quickly met by the vehicle. So this is induction motor. Then so even in Tesla car, which has very high pickup, right, very fast pickup, that car has initially induction motor as its motor drivetrain. Then coming to permanent magnet synchronous motor, we have permanent magnet synchronous motor. Here I have shown two images along with the few rotor designs. So why we need to go with permanent magnet synchronous motor is, it gives higher efficiency compared to induction motor, and also it gives high power density. So if power density is high, what happens? The weight of the motor will be reduced. So automatically the weight of the vehicle will get reduced. So it gives more range as well as better performance. And its construction is also, compared to induction motor, it will be simple. The limitation of permanent magnet synchronous motor, we have its cost is high cost. And another point is eddy current loss in magnets at high speed. That is, we have permanent magnet inside the motor. When we have permanent magnet, then what will happen? The temperature of the motor should be kept at the threshold level. So if the temperature goes high, then what will happen? The magnet will get into saturation quickly. So the it will go to the demagnetization will be happening, and the life of the magnet will also be an issue. So this permanent magnet synchronous motor, that is the 2 points which we have: high cost and eddy current loss. In magnets, that will reduce the life of the battery, so that has to be taken care of. So what's supposed to be done? We have to increase the cooling mechanism. So the cooling mechanism, nowadays liquid cooling came up, and so very fine, like the coolant is passed through the conductor. To that extent, the cooling mechanism is getting improved in all the EV. We know that the electric vehicle has to be operated at higher temperature. The motor should face that high temperature. That stress will be there. So the cooling mechanism supposed to be given in such a way. So in permanent magnet synchronous motor, there are two types of PMSM is there. One is surface mount PMSM, and the other one is, we call it as surface mount PMSM as SPM, and another one is interior permanent magnet, IPM. SPM and IPM. So both are based on the magnet's placement in the rotor, where we are placing the magnet. That is based on that it is classified, and normally we'll be using IPM motors for this EVs. So interior permanent magnet motors will be used. So recently in this, which are the cars we get PMSMS? Toyota Prius is there, Tesla car is there, and BMW i3 version that has this permanent magnet synchronous motor, so whose torque capability will be to 280 Newton meter, and the capacity kilowatts and so on. So this is one thing on PMSM. So next one is the switched reluctance motor. So we understand induction motor. So induction motor will give better performance, but PMSM can replace induction motor, so that because of its high power density and higher efficiency, so PMSM is preferred nowadays. And since it has magnets, the excitation issue may not be there. So permanent magnet synchronous motor is used in electric vehicles. The next next motor, we have switched reluctance motor. So reluctance motors are working with reluctance torque. And on our induction motors are operating based on the electromagnetic torque, that is Lorentz force. So this switched reluctance motor is operating or giving reluctance torque. So how it is operating is, the rotor rotates in such a way to get reluctance position, so that the maximum flux density can be enabled, or maximum flux density can be ensured. So this switched reluctance motor, and there are two types of reluctance machines. One is switched reluctance motor, the other one is synchronous reluctance motor. So switched reluctance motor is giving very good performance, and synchronous reluctance motor is still giving better performance in like efficiency, higher efficiency and other performance. So this switched reluctance motor, what are the special features are, it's a torque component, that is it gives a high torque. And another point, there is no magnet in SRM. Since there is no magnet as well as there is no brush, it is getting less maintenance. That is, the maintenance is very simple in SRM. Also, it gives very high operation, very high speed operation. SRM can give high speed operation. So its excitation will be like stepper motor excitations, which will be switched. The switcher based on it is excited, the one after another. So the speed will be based on the excitation speed. The motor speed will be uptime. And another point is the loss is also very low because the rotor has no windings. The rotor has no windings. In induction motor and synchronous motor, we have windings. In permanent magnet synchronous motor, okay, we have the magnets in the rotor. So here SRM, the rotor does not have winding as well as magnet. So it gives higher efficiency because there is no losses on the rotor. The winding losses are less, as well as the contact brush contact loss is also not there. So when power loss is less, the efficiency temperature will be low. So automatically the cooling mechanism will be simpler and the efficiency will also be high. So this is another, we can say it is a doubly salient machine. The stator is also having the salient pole construction. Rotor is also having the salient pole construction. So this is switched reluctance motor. And this switched reluctance motor, just it is how the reluctance torque, we are obtaining in SRM is shown with this two diagram. So if the rotor tries to get aligned to this stator, so that it occupies minimum reluctance position. That is, when each coil or each phase on the stator is excited, accordingly the rotor rotates and gets aligned with the stator. The problem in SRM is its main problem is torque ripples. Because of the switching which is taken place on the windings, that is excitations are changing, the torque ripples will be current ripples will be there, so torque ripples will also be there, and we get acoustics problem, but its inertia is also low. So these are the limitations which we have on SRM, but it is preferable for electric vehicle. But this switched reluctance motor is not on the market. Recently, PMSM and BLDC is there. Even induction motor is also there, but PMSM is recently occupying all the vehicles, all the electric vehicles. So next, when magnet is getting availability of magnet is a problem, then we have to move on to switched reluctance motors, as well as synchronous reluctance motor. The next motor type is synchronous reluctance motor. So this synchronous reluctance motor, actually this image which is shown here is the machine which is given by ABB, Allen Brownlee. So this synchronous reluctance motor, it has the construction. Stator is like our induction motor as well as synchronous motor. Stator is a three-phase distributed winding. But rotor construction, it is very complicated construction. It has there are two different rotors. Rotor images are shown here. So which has, one is axially laminated rotor and another one is transversely laminated rotor. So the lamination as well as the rotor manufacturing is tedious in this synchronous reluctance motor. Once this issue is overcome, then this SynRM will give very good efficiency, even up to 98% efficiency. We can get it from synchronous reluctance motor. Its limitation is the complicated rotor design, and we get the torque versus current curve will be somehow non-linear. That has to be overcome. So the future, we will be expecting synchronous reluctance motor on market, not only in electric vehicle but also in all the industries. The induction motor will be replaced by this synchronous reluctance motor because the capacity of since efficiency is higher, so the we can replace the 4 induction motor can be replaced by 3 synchronous reluctance motor, so that it can meet the power requirement. So in such a way, the synchronous reluctance motor is coming up. This is another type, but which is now it is coming up, not yet on the market. So then another machine which we are receiving is axial flux machines. So axial flux machines, sorry for the disturbance. Axial flux machines which are having concentrated winding, it is not having distributed winding, but the flux linkage will be enabled faster, and because of that it gives higher efficiency and better performance, and its size will be very compact compared to all the other machines, the radial flux machines. So the flux will be it will be like the construction will be, you can see stator is there in all radial flux machines. The stator may be outer part and rotor may be inner part, or or vice versa. The outer rotor motor, BLDC motor, hub motors are outer rotor motor, which is there in two-wheeler. If you see the BLDC hub motor, the rotor will be on the outer side. The stator will be kept inside. So we get such kind of configurations in vehicles. But this axial flux machines, you can see it has a rotor and stator side by side, so that the flux will be traveling in an axial manner. So this can also be used in heavy applications. So here, by having all those points, we get one comparison table with all the motors which are available, starting from DC, induction motor, PMSM and SRM. So if we see the characteristics, the power density, efficiency, controllability. Controllability means the speed and torque, how it can be easily controlled, and whether the motor can be operated in all the 4 quadrants, or we can say especially for electric vehicle, motoring mode and regenerative mode. In these 2 modes, how it can easily perform, and then the reliability and technological maturity, cost. These are the factors which are considered. So if we see power density, if we take power density, the power density for DC motor it is very low, as we understood, and induction motor power density is medium. Induction motor is giving a medium performance in most of the points, And then power density is very high in PMSM. That is why in recent luxury cars which are having in this PMSM, so that the weight can be reduced and the performance can be very high. And then power density is medium in SRM. SRM we get it is like induction motor. As far as power density is concerned, induction motor and SRM can be grouped together. PMSM and even BLDC, its power handling capacity will be less. So we are not preferring it for four-wheelers of higher end models. It may be suitable, for example, if we want to retrofit one Alto car or a nano car, we can go with the BLDC motor with some gear attachment. With one gear attachment, we can go with. So that is their first point. And then efficiency, DC motor is low, we know, induction motor is medium. So PMSM is very high. So these 2 points, the efficiency and power density, PMSM is there in all the recent electric vehicles. And SRM is doing good like induction motor. Then controllability, DC motor, it can be very easily controlled, but nowadays it is not used. And the induction motor, it's we have this speed control, director control technique is there. This field oriented control technique is there, which is easily, efficiently we can control. We can have the controllability in induction motor, and SRM is also having medium. And then the reliability, always induction motor is giving high windings on the rotor. The SRM is also giving more reliability, and PMSM is having comparatively low compared to these two motors. And technological maturity, except even PMSM is also giving a very high, it is going to reach very high point, because recently all the vehicles are with PMSM. And then SRM, it is giving, it is getting matured. And cost-wise, PMSM is very high. Cost-wise, PMSM, then SRM, then induction motor, then DC motor. These are the comparisons we have. So based on the like for which vehicle, for which applications, for luxury cars, or for if you want to go with high speed and high torque, that is higher acceleration capacity, then we have to select the motors accordingly. So PMSM is playing role. And the another point is, along with this, the motor alone is not the consideration. With this, the battery and battery management system, the BMS, those are also to be considered along with this machines or along with this motor. Then only the EV will be fulfilled. So this is only on the electrical machines. So this electrical machines, actually, it is not be liked by many of the people, because what is there in machines, control the wheel and operate the wheel, that's all there. But actually the motor is playing vital role in EV. So if we get a very good battery capacity, the mechanical structure, everything, but ultimately the drivetrain is our electrical machine. So we have to work on this electrical machines. So here I have listed out some of the research opportunities which are emerging. So few of the topics I have mentioned. So it is going to give the controllability. It is going to give a better torque speed characteristics and better changeover from normal motoring mode to braking mode, regenerative mode, and it will adapt itself. Likewise, we have some of the new aspects in machines. So one is multi-phase induction motor. So multi-phase induction motor, nowadays, this is one recent area in which we can have. This is our multi-phase induction motor. 5-phase induction motor image is shown here. So what are the advantage of using multi-phase induction motor is, if you get multi-phase higher, if we increase the phase number of phases, one point is if any one of the phases is disabled, we can get continuous power so that we can drive the vehicle. And another point, it can facilitate the different operating cycles of EV. As we have seen previously, like induction motor, the constant power, constant torque regions, or I can say during acceleration, it can be operated at high torque mode, and during regenerative braking also, it can be adapted quickly. So this is multi-phase induction motor. Another point is, multi-phase induction motor can give you different speeds with the combination of phases which we are choosing it for operations. Actually the angle between the phases, either we are choosing 60-degree mode of operation or 45-degree mode of operations. Based on that, it can be operated at different speed. So what happens, it quickly gives the different gear mechanism, that is the torque speed character. It will match, the multi-phase induction motor can match itself with the IC engine torque speed characteristics with different gear, because we have gear 1, gear 2, gear 3, the torque speed characteristics of all the gears are there. With that, we can map directly this multi-phase induction motor, so that the gear changes in IC engine can be directly obtained with this multi-phase induction motor. But the problem is, we will have more switches. So even we can use multi-level inverter with this multi-phase induction motor, so that it can be used in electric vehicle. And there is one more application for this. It is used in wind turbine also. In wind energy conversion system also, we can use multi-phase induction motor because different speed adaptation is required there also, so we can use this. And another one topic is induction motor with pole changing method. That is, pole changing configuration means it is like pole amplitude modulation technique. Pole amplitude modulation technique is known to us simply by coil inversion, and like a 4-pole machine can be operated in 2-pole mode also, or I can say an 6-pole machine can be operated in 8-pole or 10-pole. So this is pole amplitude modulation technique, and due to time constraint, I didn't take elaborate concepts under these topics, but these are the emerging area, because pole amplitude modulation technique can give you 2-speed. The 2-speed mode of operations of machines or motors are required for EV, like gear mechanisms. Then there is one more option. This is available in few of the sports cars, that is combining Lorentz force and reluctance force, or we can say Lorentz torque and reluctance torque in PMSM. So this is in PMSM also we have this concept, which maybe it is another research topic. We can be interested, means you can get into the literature survey so that you can apply any of these control technique. Okay. Then in our institute, one of our alumnus called Kaushik Kannan, he's passed out in 2019, and he was interested in entrepreneurship, so, and especially on EV sector. So what happens? He approached our department, and we took him to the principal madam, and our management madam approached our management and got seed funding for him in order to get into IIT research park for this innovation center. So he got internship in IIT research park with our guidance, and this is the auto he retrofitted. So his company firm is registered as Mikilos Motors. It's a startup. Past 6 months, he's working in IIT Research Park, Chennai, and along with Mr. Selva Ganesh, he is doing. He's working with this retrofitting of auto. With what he used is he used a 3 kilowatts BLDC motor along with controller. That's all. So it's a kind of a setup which can be fit into, which can replace the auto IC engine in this auto, so that it can be readily used in on road. So this is the pictures which is shown for his internship in IIT campus, IIT Research Park. So the next one I wanted to show you is the design and development of I'm sorry, the spelling mistake is there. Development of SRM. This is actually one of our UG students project they have done, and which is now merged with one of our research scholar also. They are trying to do design and development on new design and development of a switched reluctance motor of 2.2 kilowatts capacity. And this project we have done it in collaboration with one industry, one machine manufacturing industry. So we have ANSYS electromagnetic software. So with this specifications like 1880 RPM, it's a 8/6 SRM with a 10 ampere rating. So with this theoretical calculations, they arrived with these dimensions. The outer diameter, inner diameter of stator, rotor, air gap, everything, we got these values. And since this is given by the theoretical calculations, and after simulating with the ANSYS electromagnetic software, we got suggestions from our external industrial expert and modified some of the dimensions so that we got the performance like this. So the losses, we were able to reduce the losses. So these some of the design parameter he modified based on the thumb rule, and accordingly the efficiency is improved from 76% in simulation. We got into 91%, and these are the results of that ANSYS software. So ANSYS software, I think if you are aware of it, you could understand all these things. There are two simulation modules are there. One is under RM Expert, and then we have another platform, Maxwell. So the RM Expert, we got these images, these geometrical results, and then we verified it. And then this is Maxwell SRM. So you can see this stator, rotor, Stator has eight poles. That means it has 4 phases, and it has to be excited so that the rotor will rotate accordingly. And this is the rotor, stator, and then the shaft, and then the SRM coils, and this is complete machine on Maxwell results. Then this is what the flux in Ansys Maxwell we got the flux density distribution. So since only one coil, one phase is energized, we get the flux distribution accordingly. We get the flux distribution from one phase to it is coming out of north pole and entering into south pole. So this image we can design our own machine using Ansys software, and we can go for validation. We can simulate it and we can validate it, and then for manufacturing we can proceed. So this is, I think this will rotate. So you can see this. If the coils are energized, excited continuously, the flux distribution will be changing. So this is what I wish to show you. Not only for electrical vehicle, for any of the applications. If you are thorough in electrical machines, there are core opportunities are more. So you can enter into any of the core industries. So I hope I have given some of the very basic ideas on why we are choosing the particular machine for the vehicle applications. You can match with any other applications also, based on the characteristics of the motor and the torque speed characteristics also. Thank you.
Honorable Chairman, our Managing Director and General Manager Development, I have been asked to propose a vote of thanks in front of you. This webinar is hosted by the Department of EEE in FXECE. I like to thank our beloved principal, Dr. Vel Murugan, for organizing this event in a successful manner. Next, I would like to thank our beloved HOD, Dr. P. Annapandi, for encouraging us for organizing this event in a successful manner. Next, my hearty thankfulness to all the participants who can spend your valuable time with us. Thank you all. Last but not the least, I would like to thank our resource person, Dr.S.Allirani, Associate Professor, Sri Ramakrishna Engineering College, for his wonderful session. The ma'am you put out this section was excellent. Thank you all. Thank you for your participants. Thank you all. Thank you.